Hello, and welcome back to This is the Year, the Swiss-based AI engineering podcast. And yet again, with me today to discuss all things AI and China, as well as some chip production and some high bandwidth memory production forecasts for 2026 and prompt engineering best practices. With me today, João. How is life in Portugal? I think you're also entering the fall season post-Halloween. But
It has started to
how is
rain.
it going? Yeah.
Metaphorically and literally, it is raining. The stock market also is a bit gloomy, but I think it's just the winter. It's only a little bit. People are not going on the beach vacation so much. I think that just has somewhat of an impact on Nvidia, and thus for the rest of the markets.
Or the other way around, they need to sell the stocks to purchase the Christmas gifts.
Probably, yeah. Did you learn Chinese when you were young, Cyril?
I did not.
You
Shishi
didn't.
and Ni Hao are the only two things I know. I've been to China several times and probably, the major cities I've been, but to be honest, my Chinese is a little bit on the weaker side of things.
That's the thing. People kept telling me that Chinese would be important, and I think I agreed back then, but it just seemed to be too hard. But now I start to regret it more and more. Not because of the current political climate. I don't really care about that at the moment, but the Chinese AI models that are coming out there, and the Chinese AI labs that we're seeing popping up, disappearing out of nowhere. Some of them are still around and making a lot of big waves in the market. It's making me want to reconsider things. Maybe I'll have to invest in some lessons. So, people I think remember DeepSeek, like the model when it came out. It made Nvidia crash their stocks about 10%. Like people got really scared just out of the thought that maybe Nvidia isn't so important or so critical to this AI creation, this LLM creations, LLM training and inference as they thought. Well, that's been, what, a year ago, I think?
I think it's
almost
been a year and 2 trillion in market cap ago.
Yeah,
it's like around when they reached 3 trillion, I think. Now they're at 5.
But that was the first model. And DeepSeek has still continued to launch new models. I mean, they're not launching as often, every 2 weeks. Every 2 weeks you get a new model, but it's from someone else different. Like a new company launching, or Anthropic updating their own lineup, OpenAI updating their own lineup. And so when DeepSeek launched, they had some impact on the market. They kept launching models, and this new latest model that they released is now natively supporting Chinese hardware. It's not making as much waves now because people know that there are competing models. So the news not there, the people are not super into the research that's happening. But for someone like not only investing in the stock market, but also deep in the LLM world and what's coming out, this means that not only you're gonna have a lot more chip manufacturers, because one of the things that was keeping Nvidia up was they had the driver support, they had software support. So everything you ran, if you wanted to do inference, you had to do the training easily, you ran on Nvidia GPUs. And now you can have almost the same workflow you still can develop. You can still run training and inference, but you can have a different kind of chips. You can have chips from China, you can have chips from different brands, and they're getting support. The new model natively supports it. I think they're having more and more models from more labs that are supporting these. And they're not the only ones. So we talked a lot about the Queen models from Alibaba. They're still like one of the biggest open source models out there. If you're doing your own setup, or if you're looking into open source models, the Queen models from Alibaba are probably in your top 5 picks, depending on your use case, but usually in the top 5, if not in the top 3. And they got really, really good at video models. Because I think, and we mentioned this a couple episodes ago, that LLMs were big and were great and had a lot of use cases, but people were trying to find the next feature, like where next. And I think the video input, like being able to parse images from around the world, like images from documents or just images from a video camera in a factory, or analyzing like the road, taking the world as an image or as a video, was really, really like powerful for whatever use case you can think of. And especially for your Cyril, I know like you like the robots that we'll eventually have. And so having these AI models capable of understanding the vision, the image around them, was a good thing. And Alibaba, I think now, is their video model, the one model, probably in the top 7 of most leaderboards. And there are a lot of leaderboards, there are a lot of benchmarks, so I don't want to. They keep changing every day. But the last I checked, at the current date, that is the 6th of November, that it is one of the top models. And they're not the only ones. So ByteDance, the guys from. Have you heard about ByteDance, Cyril? Do you know who they are?
I've used the one or the other times TikTok, I think.
Yeah, so they are known for TikTok, yeah, but they also are going hard on image models. I wonder why. I do wonder why. And their image gen model is now one of the top models in the world. And not only the image generation model, but the video generation model. They're beating the Sora models from OpenAI. They're beating the VO3 models from Google. And so, like the model that we talked about and the model that very many episodes ago, people were calling me out for not hyping VO3 enough because it was so amazing and I should have hyped it up more as marketing. Well, these ByteDance models are better than VO3. They can make somewhat long clips, about 15 seconds or even higher, and they can make like, the quality is just really good. And if you go to these leaderboards, and again, I think we have one called Vision Arena, which is people actually voting on the output of these models. People keep voting for the outputs of the ByteDance models. And we have many other companies.
The long story short is it's many new Chinese models. Which one would you say
and
is
many new
it?
companies.
Many new companies, many new models.
It's very hard to pick out like which one's going to make it because they're focusing on different things. I mean, DeepSeek is like a reasoning model, very text-based. Some other companies are focusing more on the vision part, on the video part, video inputs or video output. And you have like these smaller Chinese AI labs who come up out of nowhere. They launch like a state-of-the-art model and then they disappear. I think we were talking about it before the episode. 01 AI was one of them. They appeared in the news. They were like top of the leaderboards, at least top 5 in most of them. And then they're gone. If you try to find them online, I mean, there's no website. You can try to find some information on Wikipedia, but it's very sparse. So it's very hard to predict where the next big thing is going to come from. But I'm very happy to have this level of competition and this amount of competition that is coming out of China.
I think it's it's a good, thank you for summarizing the Chinese landscape. I think just accordingly to the Harvard Business Review, a book that I've read many years ago on competition, you would want to have competition again for both parties, in that case, China and the US, to improve themselves ongoingly and continuously. If there is no competition, it's very difficult to advance any society, or in that case, such a difficult technology. Maybe just, you mentioned many models, and I can maybe quickly just tie the knots here on what's actually enabling these models to be really becoming actually state of the art. And there's just 2 or 3, I would say, trends I would be watching out for / without financial advice in 2026. That's mostly the
not
high
legally
bandwidth
financial
memory.
advice. It's
not
legally,
yes.
but for most cases,
from a standpoint of training the models, aka again, you have to train transformers. You would need a particular amount of chips. You need a lot of compute, which is basically sitting in a data center. You need electricity. Then to run the models, and that's the third scaling law. Maybe I can put it quickly on the screen here. It also NVIDIA pointed out even some while ago. We have reasoning capabilities. We need a lot of reasoning engines. We need memory in order to execute that and to basically be scaling that third law. And that's probably just looking into the future, where most likely the bottleneck might be. It's not in the chip domain, which is the world of NVIDIA and the world of AMD, and maybe Broadcom into the future, or also Google announced very new chip called Ironwood, just a new generation of their chips. There's these chips, but also I think that the focus also for Chinese model is mostly on the high bandwidth memory, which might be the bottleneck for 2026. There are just a very small set of companies that we talked about it. For example, in January this year, these are Micron, SK Hynix from Korea, and the Chinese equivalent of these companies, something I would probably deep dive a little bit if you would be interested in memories, is CXMT, which is a Chinese memory creation company. This is a non-public company. They're about to IPO, I think, in the first quarter in 2026. To raise capital, so it's still a private company. But it's certainly something that's in the Chinese stack most likely is missing. They have SMIC, which is the Chinese equivalent of TSMC, the Taiwan Semiconductor Manufacturing Company. And funny enough, SMIC is actually Semiconductor Manufacturing International Corporation, which is the Chinese equivalent of the SMC. So they're trying to brand it more international, whereas the SMC is more Taiwan. That's just a wording and nomenclature detail here. But they do have, again, the capability to develop seemingly these chips now. Again, you mentioned the talent before. They have the capability to produce them most likely in millions in quantities in 2026 and 2027. And the only bottleneck, once again, is HBM or high bandwidth memory. If Micron and SK Hynix are actually enacting certain export controls on memories, which I don't think they're going to do anyway. But they will have some sort of this constraint, and in electricity, they're completely fine. China is building roughly an order of magnitude of 2 times the US capability of generating electricity every single year. So they're more or less doubling the US output every single year. In China, they're mostly doing that with a mix of nuclear and solar and so on and so forth. They still have a lot of coal there as well, but they don't have a constraint on electricity whatsoever. They don't have a constraint on chips. Potentially, they might have a constraint on the memory side of things. So that's a little bit let's say the foundation layer on infrastructure in China. It's a super interesting thing. Also, I put the article here on the screen here. It really goes into detail by Semi-Analysis. It's a cool blog if you haven't heard about it. That's basically just, again, doing some super detailed investigation into research of AI infrastructure, both chips, high bandwidth memory, and all the interconnects and so on and so forth for the world of artificial intelligence. Joao, do you have any other topic on the Chinese front, or should we move on to the Saudi front or any other international?
A final one, which I think will unlock a lot of good capabilities for the rest of the world, which is a piece of research coming from Moonshot AI, the guys from the Kimi models. Again, for the ones not keeping up with open source ones, Kimi models have been for the past few months one of the top models in the open source leaderboards. And Moonshot AI has been really strong in not only releasing these models, but also the research that they output. And the latest research, it's a very simple thing. It's called linear attention. The attention is the primary mechanism on the architecture of these models. Like attention is how they read text, basically, and what do they look for in the text while they're making more and more text or more video or images, depending on the model. And usually attention is quadratic. So if you want to have double the input, if you want to have more context, you're going to have a lot more memory. And so it makes these models big. We talk about open source models, like they're online, they're free to download, but you can't run them on most computers because they're heavy. They are gigabytes, sometimes 100 or more gigabytes of RAM that you need to run. And linear attention means that you can now, besides quantizing the models, the primary architecture, the primary mechanism that these models work on is now much more efficient. Like there have been some research about different mechanisms, different attention mechanisms to try to make it not as memory intensive, but they had some drawbacks and they weren't really scalable. So the new models kept using the normal attention mechanisms, sometimes optimizing on them, that different models have different ways of doing attention, but they were still using like the normal attention mechanism that's like normal to the LLMs. This linear attention makes that you can run these models on a much smaller GPU in a much more feasible scale, which means for the worldwide web and for all the countries out there that are interested in getting into the AI race, it means it's now cheaper, or it will be in the very near future, cheaper to get into making these LLMs, training these LLMs, and also for the companies out there to run them. And I've seen more and more of people and companies, especially smaller companies, building up their own AI hardware stack so they can run their own agents locally. I mean, for most businesses, you can just have like half a room or like a couple stacks of GPUs, and for 20K, 30K, 40K, you build this like hardware stand on your office that you can run your agents that are much cheaper to run than like full employees, and you can make a really good profit out of optimizing your workforce, and you don't have to worry about outside inference. Again, don't have to worry about putting your data somewhere else. It just makes it really cheap and accessible for companies to run their own AI models or run these open source models without having to go to OpenAI or Anthropic.
I mean, it's a good conundrum. I'm not a particular super detailed expert in linear attention, but maybe it's again struggling in reasoning capabilities and maybe detailed patterns. But certainly I think these developments are important. again, to make the process of developing them more feasible, potentially faster, maybe cheaper to build. Again, maybe the last notion, or if we then close up on the international side of things, is just some announcement that I thought is again super interesting, coming from the Middle East, Saudi Arabia. I was visiting Saudi beginning of 2024 and 2025 once again to Riyadh. Every time I go there, it's a super interesting and fast-paced environment. And now there is one very large player there called Humane. You might have heard about them. I put them on the screen here. And one particularly interesting component I just took away from one of the discussions we've had in Riyadh is running inference very close to the electricity source, meaning in the case of Saudi Arabia, they have an abundance of energy. But at the same time, because the latency is still in a particularly low range within Europe, many European companies, maybe even African companies, depending on how the cables are set, the sub ocean cables, you can do inference using the data centers in Saudi Arabia that Humane is building. It's giving them access to around 4 billion potential customers that can run inference, again, using Saudi Arabia's data centers built by Humane. They're mostly running on Grok, not the Grok from XAI, but the other hardware Grok, basically. I just thought it's an interesting nuance just to add. There is the Chinese players. Again, they're building their own chips. They're building their own HBMs. They're building their own capabilities to manufacture advanced chips and so on and so forth. And Saudi, as probably the third largest player in the world, has the capability of infinite energy. They also have the capability to access, with very low latency, 4 billion people within Europe. Especially if you're a European builder, it's maybe a market to be checked out if you want to be inferencing at potentially very low token costs. If it's not super data sensitive and you have to run it within your local region. For example, Switzerland for finance, healthcare, and so on, the data there. But you maybe have less sensitive workloads that you can then go run in Saudi. And the latency, once again, back to Switzerland, back to Germany, back to Austria, is low enough for it to make sense. And you might have 10 times less compute cost if you do it on AWS or on Azure Switzerland or Azure or AWS Frankfurt, for example. I just thought that's an interesting nuance to add. Again, Humane, I'll put it on the link as well to add. Maybe let's quickly wrap the episode up, Joao, with some context engineering. Context engineering, just maybe looking into 2026, is it becoming more or less important in your opinion, especially if we have AI agents, AI XL agents, something we've been building? Where do you see this going?
I think you'd hope that, or you'd think that it's becoming less important because you'd have more GPUs and better models. So it doesn't really matter if you're too picky on what to show the model. However, there's one other thing that's making them important again, which is a lot of these MVPs and a lot of these solutions are going from prototypes to actual production. So to dozens, potentially thousands of different clients, people using these models. And so we were testing out like how to make and match these LLMs with XLs and make them work within XLs. And we quickly found out or came to the conclusion that it uses a lot of tokens. And there's ways to optimize that, and there's different approaches into making LLMs work with XLs, but all of them require at least quite a few output tokens, which are the most expensive type of tokens, but also quite a bit of input tokens to make the XL actually matter for you. And so unless you want to run like a $20,000 like prototype, even before it have a lot of clients, you'd have to worry about context engineering, because yes, you can show 3.5 books to your LLM of choice. Maybe they all fit a context window. However, that does get very expensive very fast. And so just for a cost perspective, I mean, for you as a startup building like an AI solution, or for you as a company building the AI agents to help your business, but also like for whoever runs these models, like the less context they have, the more like the less power that they use overall, the easier it is to batch different requests together, and so to make it more efficient overall. So context engineering, I think, will become a theme and will become important, and it will remain important, I think, for the 3 to 4 next years. Maybe there'll be some groundbreak research where we can run these models for free using the power of the sun. But until that happens, you have to be selective on what to show. And being selective means understanding the different layers of context engineering, different kinds of messages that they could show these models, and understand how these models are trained so you can make the best use of them because different models respond best to different kinds of formats. They all, I think, understand Markdown really good. But the way that you show this context, the way that you parse it, the way that what you select to show it when, for example, you're doing RAG, like the research, you don't want to show the whole internet all at once to the model. It might find what you want, but it might not, and it will certainly be costly.
Maybe I can just re-roll up the context of the context engineering importance. I can put it on the screen here maybe quickly. Why it's really key to actually engineer what goes into the LLM in the best possible way. One is price, but also the other side is the attention mechanism itself. Like you can think about in a large language model like a human, we have limited memory capacity. Once we look at a particular problem, the same large language models, they have some sort of an attention budget they can draw on when parsing through large volumes of, for example, data within a particular context. For example, you can put anything in a context you would want, or that's the wishful thinking many potential solutions would be wanting to go for. For example, many documents at the same time, many different informations regarding tools, memory files, so your entire chat history of your clients, very comprehensive instructions, maybe some particular documents at the same time regarding domain knowledge and so on and so forth. And the art, or also the science of context engineering is just to drill down and only give the model what is truly meaningful. Again, given a particular set of limited tokens, the large language model with the attention can actually process. That's a little bit the art of context engineering. Prompt engineering is simply you give some sort of an instruction within a context window and then it executes it. Yes, you need to engineer both the system and the user prompt in the most effective and strategic way forward. There is many also mechanisms on ideal system prompts, not too detailed, not too vague in the first place. But context engineering is a lot more complex. It's a lot more a science. It's a lot more an engineering problem. Again, trim down the possible context to the actual meaningful context. You need to think a lot about what's needed and actually to compute a particular output or to compute and ask for a tool call, for example. So that's a little bit the difference. Very simple, like humans, basically.
Yeah, and this like specialization, that's what like did the rise, or that's why we started doing multi-agent systems. It's exactly to not have a single LLM call, not having a single agent try to take in all the information. We started to do these multi-agents where each agent just preoccupies itself with one single task or one single topic, and then this can just bounce one task or multiple tasks around. And in the later stages of your process, you can just gather all the information. So you can get the information from the researcher, you can get the review from the reviewer, the analyst, you can combine them all. Maybe you run either a review or an analysis on your answer. That does it match like your sources? And you can build these multi-agents exactly just to make sure that each agent focuses only on the task at hand. And the more specific the task is, usually the better results you can get. If you ask for a recipe of a cake, at the same time you ask for what's the best stock to invest, maybe you won't give the greatest of advices. Maybe you should invest in a flower company. I don't know.
Exactly. I mean, once again, prompt engineering, I think, was like the buzzword of 2024. And I think context engineering probably late 2025, definitely early 2026, when we have a lot more multi-agent systems running around, consuming vast arrays of possible context inputs. And then we need to have smarter choices to actually combine them. There's also many more mechanisms on top of that. For example, if you use MCP, you might want to have a governance structure, for example. That's also a new and the rising domain. For example, human in the loops. How do you actually make sure not an infinite amount of tools are getting called? But maybe we can talk about that in the next episode next week. Anything else from your side, Joao? We talked about Chinese. Very fast advancements. I'm truly excited to go back to China very fast and very soon. We talked about Saudi. Also very much looking forward to go back to Saudi and talking to the experts there. Talked about prompt engineering, especially in the context of AI XL agents. Anything else would want to go for?
I'm looking forward to bring up European news on AI in the very near future. I know we have NN as a startup in the world, but that's we certainly need more, a bit more waves in the market and a bit more of a spotlight. And so I think the next week's episode, I'm hopeful that Europe will have some news, if it's on the regulation side. Even if it's bad news for the startups or the ones developing the LLMs, it's still news and it's still important.
Exactly. I mean, especially Switzerland, it's and also Portugal, two major tech hubs within Europe. A lot of things are happening. It's just the major news usually comes from the model providers, from the service providers, meaning the clouds, or some sort of very specialized startups that just got another multi-million-dollar funding round. Also,
I can give you,
yeah,
I can give you some insights on like NVIDIA announced that the first data center in Europe would be in Portugal. They did a deal, and they're setting up like this huge, like thousands of GPUs and data center. I think somewhere in the middle of Portugal. And they announced it, and you saw like a wave of news across national but also international channels, like the creation of jobs, and like this would advance the industry. And then, as a Portuguese person, I can go to the local forums and know what people are thinking. And I saw a lot of people worried, and maybe the majority of people online worried about the energy consumption, the water consumption of the data centers, and skeptical about how much jobs and how much of like value does it actually add to have the data centers. So it is a big thing to build up like these data centers in Europe. It is not, I think, as easy as it is in the US. Locally, you will, I think, find some resistance because, again, you're using up a lot of resources. You do have some jobs for people, but it's also mostly automated, or it should be in the very near future, mostly automated. And so it keeps me a bit hesitant and a bit skeptical of the future of European inference, on how hard it is or how easy it is to build up the data centers to have inference within the GPDR region. Otherwise, you have to go to US, maybe go to Saudi Arabia for inference for your AI startup.
It's usually, I think the master plan is you get these token factories very close to the to the electricity sources. In Switzerland, there's also a lot of water electricity because we have these lakes in the mountains that are running on different levels. So we can let the water flow down when we need electricity, and we pump it back up when we have basically too much electricity on the grid. So there's a little bit the balancing factor. Maybe we can just add a data center there. Somewhere sitting in the mountains. It's actually cooled, and it's maybe also hopefully low latency. And again, we have an infinite amount of water we can pump up and down. I'm definitely not an engineer, and I can pitch that, but
I mean,
it would be interesting to use a lot more.
If your pitch deck includes the word infinite amount of water, you might have some skepticism from investors. You have a lot of water. Just say it's a lot of it.
Exactly. And also, if the glaciers are melting, that's not a positive news. So if the water is increasing, it's not probably coming from the rains, coming from the glacier. Okay, excellent. Let's wrap this one up. Next week, again, we tease a little bit. Ideally, we'll covering a little bit the European ground of AI development. Maybe we are covering a few startups because there is actually many larger ones also arising in Switzerland and in the neighboring countries, including Portugal as well, in the south of Europe. We probably will be talking a little bit more about HBMs and high bandwidth memory, reasoning, multi-agent systems, and context engineering. And yeah, see you in the next episode. As always, I will also put more tutorials up, just again around vector storages and the whole RAG components. Definitely stay tuned for these tutorials and see you in the next one. Show next week. Take care. Bye-bye.
See you next week.